Hello, friends. In the last few days, due to your CIE, I have decided to not conduct the lectures for your class, but for from today onwards, we'll discuss here the last unit from your syllabus from real analysis paper number 7, that is infinite series. So already we have studied here the topic sequence. Now we'll proceed towards the topic, what we call it as infinite series. So see what is the introduction of that topic. What is introduction? Infinite series occurs so frequently in all types of problems that the necessity of studying their convergence or divergence is very important. Means here infinite series occurs so frequently in all types of problems that the necessity of studying their convergence or divergence is important. Means if series is there, you must know here whether that series is convergent or divergent. It gives here very important results. Unless a series employed is an investigation is convergent, it may lead to absurd conclusions. Means there is a confusion. There is a confusion if you don't know whether the series is convergent or divergent. Hence, it is essential that the students of bachelor degree, being not only the bachelor degree but also the student of engineering, being by acquiring an intelligent grasp of this subject. So you must know if a series is given or infinite series is given, whether that series is convergent or divergent. So first see the definition of series. If here u1, comma u2, comma so on, comma un, this is given as the infinite sequence of real numbers. And if you consider here sum, that is u1 plus u2 plus so on plus un plus so on infinity, then this sum of the terms of this infinite sequence of real numbers is called as what we call it as an infinite series. And that infinite series is denoted by what we call it as the summation un. And the sum of first n terms is denoted by the sequence Sn. So thus S1 means what? U1. S2 means what? U1 plus U2. So on. Sn means what? U1 plus U2 plus so on plus Un and so on. So therefore, limit of Sn as n tends to infinity gives here limit of Sn means what? U1 plus U2 plus so on Un. And these are nothing but here the terms. You will get its limit as U1 plus U2 plus so on Un. Means limit of Sn as n tends to infinity, you will get it as summation n transform 1 to infinity Un. So you remember, if u1, u2, so on un be given as infinite sequence of real numbers, and if we have taken the sum of these n terms or sum of these infinite terms, it forms a series, and that series is known as what we call it as the infinite series, and it is denoted by this one notation. So you must know the difference between sequence and series. Then and the sum of first n terms of that series means u1 plus u2 plus so on plus un is denoted by what we call it as the Sn. So what is the meaning of S1? S1 is U1. S2 means what? U1 plus U2. So on Sn means what? Sum of first n terms of that series, that is U1 plus U2 plus so on Un. And if we have calculated here the limit of that sequence Sn as n tends to infinity, you will get it as the series summation Un where n runs from 1 to infinity. Now friends, in another words, infinite series summation n runs from 1 to infinity un may be defined as an order pair. Here un where n runs from 1 to infinity, and what is the second element of that order pair? The sequence Sn where n runs from 1 to infinity. Means infinite series is nothing but here the combination of here the series and the sequence. Sn means what? The sum of first n terms of here the series un. And what is un? Un is an infinite series where un is a sequence of real numbers here in this case. And what is Sn? Sn is nothing but the sum of first n terms of the sequence that is here un. The number un is called the nth term of the series summation un, and Sn n runs from 1 to infinity is a sequence of partial sums of that series summation un. So if you consider this as an order pair, here in this case un is not series, but here in this case this is a sequence, and Sn is what? Sn is the sum of first n terms of that series summation un. Here un is nth term, and that n term of the series summation un. And what is Sn? Is the sequence of partial sums of the series summation un. Now friends, see your given remark. As Sn is, we know u1 plus u2 plus so on un is a partial sum of the series summation un. Then we can write here Sn. Sn is the sum of first n terms. So what is Sn minus 1? Sn minus 1 means these n minus 1 terms we can replace by Sn minus 1 plus this un as it is, and from it we can write un as Sn minus Sn minus 1. We will need here this result to prove here few results from here the unit infinite series, and that's why here I have shown what is the value of un. Un is Sn minus Sn minus 1. Now onwards, by a series we mean an infinite series of real numbers, and if we consider here capital I, then capital I is what? Set of all positive integers. Means throughout in this topic, if we consider a series, then it means infinite series of real numbers. And if capital I is there, then that capital I denotes what? The set of all positive integers. Not set of integers, but set of all positive integers. Now, what is in general convergence and divergence or oscillation of a series? Or when the series is said to be convergent, when it is said to be divergent, and when it is said to be oscillatory. So already we have studied when the sequence is said to be convergent, when it is said to be divergent, and when it is said to be oscillatory. So if your given sequence has a finite limit, then in that case, that sequence is called as convergent sequence. In similar way, if you consider here infinite series summation un as u1 plus u2 plus so on plus un plus so on infinity, and let the sum of first n terms, if we denote it by Sn as u1 plus u2 plus so on plus un, sum of first n terms, clearly this Sn is a function of n, and as n increases indefinitely, means n tends to infinity, three possibilities arises. What are these three possibilities? Maybe you will get limit as finite, maybe you will get infinite, and maybe you will get different limits. If you get limit as finite, this series is said to be convergent. If it is infinite, it is said to be divergent. And if limit is not unique, then in that case, that series is called as what we call it as a oscillatory. So what is first possibility? If Sn tends to a finite limit as n tends to infinity, then the series summation un is said to be convergent. That part already we have discussed under the topic sequence, and same repetition is there under here the series. Next, if Sn tends to plus minus infinity as n tends to infinity, then in that case, the series summation un is said to be what we call it as divergent. And if Sn does not tends to unique limit as n tends to infinity, then in that case it is said to be oscillatory, or it is said to be what we call it as non-convergent. Now we'll discuss here few examples. Examine the convergence of the series. So if you consider here this series, nth term un is nothing but n. So see the solution. This is given second series, this is given third series. So see solution of first. Here Sn is what? Sn is sum of first n terms, that is 1 plus 2 plus so on plus n. And we know sum of n terms, we can obtain it as n into n plus 1 divided by 2. So Sn is a what? Function of n. Now you take limit as n tends to infinity. So limit of Sn as n tends to infinity is equal to this half I have taken it to be outside, and limit of n into n plus 1 as n tends to infinity. And this limit as n tends to infinity tends to what? Infinity. Its meaning is what? This infinite series is what we call it as divergent as per here this statement. Then if you consider here this second series, 5 minus 4 minus 1 plus repetition of the same term, repetition of the same term plus 1 infinity. So here in this case, here 5 minus 4 minus 1, such here how many terms are given? N terms are given. So if we are consider here first three terms together, then first three terms together, its answer you will get it to be 0. Means if you have n equal to 3m, then in that case 3m, its meaning is what? First three terms in this series, its value you will get it to be 0. If you consider here n equal to 4, n equal to 4 means n equal to 3m plus 1. Then in that case, value of this is you will get it to be 0 plus you will get here 5. And if you consider n equal to 3m plus 2, then what happens? If you have to consider here these terms. In that case, answer of here, this you will get 0 and 5 minus 4 you will get it to be 1. Means you will get value of Sn to be either 0, 5 or 1 according as the number of terms is 3m, 3m plus 1 and 3m plus 2. Here in this case, if we have taken the limit of Sn as n tends to infinity, you will get that limit not unique, that you will get it to be either 0, 5 or 1. And if you cannot get unique limit as n tends to infinity, then in that case, this series is said to be oscillatory. So this second series is what we call it as a oscillatory. Clearly, in this case, Sn does not tends to a unique limit. Hence, given series is oscillatory. Now, what is the third? Third is given Sn equal to 1 plus 1 by 2 plus 1 by 2 square plus so on. You will get here 1 upon 2 raised to n minus 1. If you consider here this right hand side is a geometric series with common ratio. What this is in GP with common ratio was 1 by 2. So how to obtain its sum? Its sum Sn can be obtained as first term, that is A, into 1 minus common ratio raised to n divided by 1 minus common ratio. If this common ratio is less than 1, its sum can be obtained to be like this one. That is here first term into 1 minus common ratio raised to n divided by 1 minus common ratio. And if we have taken here limit of Sn as n tends to infinity, this must be n tends to infinity. You will get it to be what? 1 into 1 minus 1 upon 2 raised to n divided by 1 minus half. 1 minus half, you will get half, that 2 I have written here. And as n tends to infinity, first term remains as it is. And value of here, this second term as n tends to, this term, second term as n tends to infinity tends to 0, means its limit you will get it to be 2. So if you get here the limit of that series as a finite, then in that case, we know as per the general definition, we say the series is what we call it as a convergent series. Now, in my sense, if you understand the meaning, what is infinite series, what is sequence, infinite sequence of real numbers, then afterwards here, when the series is said to be convergent, when it is said to be divergent, when it is said to be oscillatory. Now we'll proceed towards what is the necessary condition for the convergence. That is our theorem number 1. So what is first? A necessary condition for the convergence of an infinite series, summation un, is that limit of un as n tends to infinity is equal to 0. This un means what? The nth term of here this series, summation un. So if you get here uh, the necessary condition for the convergence of infinite series, summation un, is what? Limit of un as n tends to infinity is equal to 0. If you get limit to be 0, then in that case we say that series is a convergent, but that is a necessary condition. It is not sufficient, you have to remember. So to prove here that result, we have defined here Sn, that is here partial sum of the series summation un, Sn as u1 plus u2 plus on un, be the partial sum of the series summation un. And since summation un converges, we assume that that summation un uh, converges to what we call it as a. Means summation un runs from 1 to infinity un is equal to a. So by definition of convergence of a series, we have here limit of Sn. If here this series converges to A, its meaning is what? The sequence of these partial sums converges to what? A. Means the limit of here this sequence Sn as n tends to infinity, you will get it to be A. And further we know here Sn minus 1 is the earlier term. Sn minus 1 is the Sn minus 1 is what? U1 plus U2 plus on Un minus 1. And we know it is a subsequence of the sequence Sn. And already under the topic, what we call it as a, sequence, we have studied a sequence and its subsequence both has same limits. So Sn minus 1 is the subsequence of Sn. So as Sn, limit of Sn as n tends to infinity is equal to A, you will get limit of each subsequence, that is Sn minus 1 as n tends to infinity is also A. And then we know the result, just we have discussed in the earlier slide. Even we can write it as Sn minus 1 for all n belongs to I. And then you take limit on both sides as n tends to infinity. So limit of un as n tends to infinity equal to, you will get limit of Sn as n tends to infinity minus limit of Sn minus 1 as n tends to infinity. But we know limit of Sn as n tends to infinity is A. Limit of Sn minus 1 as n tends to infinity is also A. So you will get its answer to be 0. Means what we have proved? We have proved limit of un as n tends to infinity is equal to 0. And here completes what we call it as the proof of that theorem. Means uh, the necessary condition for the convergence of the series summation un is nothing but limit of un as n tends to infinity is equal to 0. So see friends, here we have proved easily that theorem, but it is important to note that the converse of this theorem is not true. Means that condition is not sufficient. Its meaning is what? Although the limit of even as n tends to infinity is equal to 0, it does not prove that the series summation un, where n runs from 1 to infinity, is a convergent. So see, for example, EVN is given as what? Summation EVN is given as summation 1 upon square root of n. Then in that case, what happens? Limit of EVN, if you have taken as n tends to infinity, you will get it as what? Limit of EVN is what? 1 upon square root of n as n tends to infinity, and you will get that limit to be what we call it as a 0. Because this term as n tends to infinity tends to what we call it as 0. Its meaning is what? Limit of EVN is 0, but it is not necessary. Is limit of EVN is a necessary but not sufficient condition for the convergence of EVN, because uh, that series is not convergent. So if what is second condition? Limit of EVN as n tends to infinity is not equal to 0, the series EVN must be divergent. So, in my sense, friends, if you understand here the concept of what we call it as a sequence of infinite sequence of real numbers, then infinite series, then afterwards the general convergence, divergence, and oscillatory infinite series, and afterwards here that theorem, the necessary condition for the series summation UVN is to be convergent is what? Limit of that series, limit of UVN as n tends to infinity is equal to 0, but that condition is not necessary, sufficient. That condition is not sufficient, it is necessary. And this result we have discussed. If limit of UVN as n tends to infinity is not equal to 0, then in that case summation UVN must be divergent. Now friends, today we'll stop here. In the next lecture, we'll discuss what is Cauchy's general principle of the convergence for the series. So have a good day friends. We'll stop here.